What is a theory? A theory is a representation of real-world phenomena. Ideally, a theory should be able to 1. Predict. Make predictions about phenomena, such as event outcomes or entities to search for in reality. These predictions rely on defining and matching features. 2. Simulate. Create models of phenomena using physical models, computer simulations, or language. Simulations can focus on the past, present, future, or customized scenarios, generating observations that lead to predictions about reality. 3. Organize information. Transform raw data by categorizing and labeling it. A theory should consistently differentiate between distinct phenomena and identify when the same phenomenon is observed. 4. Generalize. Reduce a phenomenon to a set of fundamental principles. These principles can then be applied across domains and mediums to build, engineer, or solve problems. 5. Define governing rules. Identify and describe the rules governing the system that allow the phenomenon to occur. This helps define the limits of what is possible, guiding the allocation of resources. 6. Store. The theory should be documentable, teachable, reproducible, and easily shared. There is no need for confusing philosophical formulations. The practical uses listed define what makes a theory. If a theory accomplishes these tasks, it is valid, regardless of any philosophical objections. If it cannot, it is ineffective and does not qualify as a theory. We have shown that predictions are made by observing phenomena for patterns, and then using those patterns to calculate predictions. Simulations are created by feeding predictions back into itself to produce the next step in a recursive loop. To organize means to categorize. To generalize is to reduce a phenomenon to fundamental patterns. To define the governing rules means to identify system regularities that are repeatedly enforced. Storing, reproducing, and communicating knowledge rely on patterns. At the core of all practical uses of a theory, we find patterns. For a patternist, a theory is the full recognition of the fundamental patterns constituting a phenomenon. A theory should seek to identify all patterns and regularities a phenomenon exhibits, including the phenomenon itself. Our approach to a theory of intelligence will follow these same principles. For a patternist, intelligence is the ability to find and utilize patterns. Through patternism, we predict that the direction of evolving complexity in any intelligent system will be towards faster and more effective means of finding and utilizing patterns. Since adaptation is intelligence, we predict that any adaptive system will consist of a randomizer, a sorter, and a flexible medium using the mechanisms of repetition, prediction, natural selection, and categorization to find patterns. We will build simulations of intelligent systems. In fact, simulations already exist in machine learning, employing evolutionary algorithms and neural networks to recognize images, generate text, translate languages, drive cars, and detect patterns in data. However, what remains missing is a comprehensive explanation of why these programs work. Scientists have replicated the biological phenomenon of neural networks in software, often treating them as a black box without fully understanding the underlying mechanisms for their functionality. Through patternism, by understanding patterns in terms of features and regularities, we can fully explain how and why these programs work, starting from first principles, as well as explain how it is possible that biological neurons can be translated into algorithms and result in intelligent behavior. Through patternism, we will examine the genetic algorithm, the linguistic algorithm, and the neuronal algorithm, discovering they all share an underlying structure, universal recognition, a single unified algorithm that operates on patterns and is present in all intelligent systems. Through patternism, we will redefine the phenomenon of intelligence. We will organize and expand the category of intelligence to include all living organisms and their behaviors, including all human activity and behavior. Our approach will surpass the achievements of evolutionary theory, creating a knowledge base that includes not only biological, but also manufacturing and technological phenomena, as well as insights into consciousness, communication, and science. What a patternist seeks in a theory of intelligence is to find and describe its fundamental principles. It is strange. To develop theories like Newtonian mechanics, the periodic table, or Darwin's natural selection, scientists observe regularities in phenomena and generalize them. Yet, when it comes to intelligence, no such process occurs. It is a seeming blindness. All those who claim to be searching for a theory of intelligence have chosen to wander aimlessly instead of using the proven methods that have produced so many accurate and practical theories. Through Patternism, we have the means to develop a theory of intelligence. We will examine all biological phenomena and use them as clues, recognizing that the intelligent and biological phenomena are one and the same. What we will uncover are the principles of representation, recognition, reproduction, and randomization, a viable set of interacting principles underlying all intelligent and biological systems. We will identify the governing rules not only for intelligence but for the universe itself. Patternism is the belief that patterns, and the paradox of the patterns, are fundamental aspects of the universe, in the same manner as space, time, and matter. We will show that knowledge storage occurs through representations, that reproduction is the propagation of patterns, and that communication, in all its forms, relies on patterns. This book itself serves as a medium to store, reproduce, and communicate a complete theory of intelligence grounded on the first principle of patterns. Finally, we will account for the process of theory creation itself, showing those interested in the phenomenon of intelligence how to craft their own theory, find their own set of principles, and refine them, if what this book has to offer is deemed insufficient.